block. I try. Every day I try to come up with something, right? Eager. All right, so in this class, we are now going to transform this new parent function. All right, those are the parent function points. What is your domain for this function? I heard -1 all the way to over yonder. How wide does it go? 5. It goes all the way to 5. Now, what's really cool is it is just brackets. Can you write this as an inequality? Yes. What letter do you have to use? X. 5 goes over here and -1 goes over here. What symbols would you use? Just so you guys know, that is pointing which way? That is pointing left. So that is a left, which is less than. Okay? So the other one would be pointing to the right, which would be greater than. And so in this case here, it starts with LE. So if you can't remember, if you're going the other direction and you're pointing to the right, R-I-G-H-T, this one has a G and an R in it, and so does what? Great. All right? If you remember, left points left. So this needs to be a what symbol? Less than or equal to is correct. It is, remember, the monster is eating the largest number. The largest number is 5. It doesn't want to eat the -1. It's the smallest one. It's going to kind of ignore that. Okay? So that's the smallest number, the largest number. So if you're going to write it in inequalities, that is the correct way to write it. Okay? I had some people who were trying to write it like this, and that's not right. Okay? All right, moving along on this one. What is your range, Carter? What's your range? What's your range? What's the bottom of that graph? What's the bottom of that graph? What's the lowest it goes? That's right, -3. And where's the top? That's right. So -3 to 1. Nailed it. All right, now we're going to write it as an inequality. Mary Beth, how would you write that? And 1. There you go. All right. So if you're writing inequality, you have to remember if you're using X or Y, right? You have to remember the range is talking about how tall, which is up the Y's. Okay. Now moving down here, some of you guys, I don't know if you took the table and wrote the table down and then added, subtracted to it. I think that's what Aubrey did. But I showed you the way you can do this on your graph, right? So what's your descriptions? What's going on here? Right, 3 down 2. So you would draw a dotted line here and draw a dotted line here. And then what do? Once you shift it left, right, up, down, you draw your parent function. And my parent function happens to be 4 points. Here, 1, -3, 3, -3, and 5, 0. And then you just connect the dots, and that was it. I didn't have to do the table. Okay? Is it okay to use the table? Yes, you can. Okay? Again, dotted line, dotted line. That tells me I'm going right 3. That's what that's doing. Okay? Did my domain change? No. Both of them change. Domain and range change. I added 3, so it shifted it to the right 3. All right? Okay. You guys need to see the table? All right, so if I was doing a table, you remember your points were -1, -2, 1, 1, 3, negative 3, 5, 0. So if I'm moving it right 3, I'm going to do what? Add 3 to my x's. I'm going to subtract 2 from my y's. When I get those points, that's 2. That is negative 4. We'll look at 2, negative 4. That's where I'm at. Okay? You can do it by the table. All right, looking at number 3. What's that say? That is your ROX, and this is your up 3. All right, so I'm going to graph this. This is the way I do it on my graph. All right, brand new to you. I don't think you've seen this one yet. Talked about it, but we're going to go up 3. You're going to draw that first. Go 1, 2, 3. Dot yourself a dotted line. Okay. Guess what? I did not move it left or right. So look where my new origin is. Okay. I will now draw my what? So once you finish your right up down, you're going to draw your parent function. That's how you do it on the graph. So I'm going to go negative 1, negative 2. I'm going to draw my 1, 1. I'm going to go 3, negative 3. And I'm going to go 5, 0 on my new grid. So I'm going to draw this dotted, or if I have a pencil, I'm going to draw it lightly on my graph. This is not your final product. All right, so it's an image, right? A pre-image, what they call it. All right, so in this case here, we're not done. All we have done is taken the graph and moved your parent function up 3 units. Okay? Now, the next thing we're going to do is we're going to box it. So this is the reflection line, not this one. I get a lot of students get confused. They reflected over the wrong ROX. We have moved the ROX, so this one doesn't exist right now. It's this one, all right? So we are going to flip it over. Reflection over X just means that this point is now going to be up here. It's 2, distance of 2 from that line. It's going to be 2 up there. That distance is 1 here. I'm just going to flip it down here and make it negative. Here it's at negative 3, so it's going to be up positive 3 up here. That one didn't change. It is on it. I'll connect my dots. The green graph is your final output. Okay? The final one. If you feel like it, you can erase the blue one if it's bothering you on your graph, but just make sure your final image is bold. Okay? I can tell that's what you ended up with. Now, to do it on the chart, remember our chart was, again, the points. I think we used negative 1, negative 2, 1, 1, 3, negative 3, and 5, 0. I have to go up 3, and then what values are up 3 dealing with? Yeah, the Y value. And I have to pay attention. What is rocks dealing with? This is your Y values, and these are your Y values. They're both Y values. I know it says ROX, but remember in this case here, it's reflection over the X, Kaylee, right? So it goes from negative to positive, so it's flipping it up and down. So it's an up and down change. So an ROX is an up and down change. You have to remember that. So that is really tough for a lot of students here. Okay? I will have mistakes made. They're going to think that that's an X because it says X in it. It's the one that, remember, X is like to you, so maybe you can remember that. Okay? It's a Y change. Now, because we have both of them are Y changes, yesterday we talked about this. Up means we add, right? But rocks means that we multiply. We have to follow what again? PEMDAS, which is the order of operations, so we must multiply first. So you would take each of these and multiply them by a negative 1 first. That will give you a positive 2, a negative 1, a positive 3, and a 0. Then you will add the 3 to each of these after you do that. Okay? Switch the signs by multiplying by negative 1. That's what these are right here. Then I'm going to add 3. In my final result, I'll just do it in green over here so you can see it. That's going to be a 5. That will be a 2. That will be a 6. And that will be a 3. So your points are 5, 3. Let's see if 5, 3 is on this graph. Oh, 5, 3. 1, 2, 3, 4, 5. 5, 3 is right there. Okay? Now, when I'm doing the chart, I'm using the original origin, not the new one. Okay? So the chart kind of eliminates the dotted lines in that case. All right? So, for instance, if I was looking for this one right here, which is negative 1, 5, take a look. Negative 1, 5. That is that point. Okay? So you have to follow the order of operations in order to get this one right. That's why order matters. So when you're writing it down, you cannot put ROX on the backside. It has to be in the front because you would multiply before you would add. Okay? Any other questions on here? Oh, you can find it. I was like, going, wait, I thought is there more? You got me. Good job. All right. So questions? Comments? You getting better at it? All right, moving on to homework. That's my computer science class. I teach computer science. Get that from? Oh, another light right there. Yeah, bunch of them right there. Okay. I don't know if it's a bunch, but I have like. And then if I really are desperate, you got anything for me? Oh, thank you. How old are these? This year. Sure. The high corn producer is brand new. That's the episode. It would if it was still really. I wrote the seal like last week, so. All right, we're doing number 1. Peyton and Abigail, do number 1 on that board. Number 2, Lydia and Max. You're going to do number 2. Lydia, you're going to write on the board. And then she's going to support you. Marie and Elijah, you're going to do number 3. Right there on that board. Madison and Annie, you'll do number 4. Just do right there. And then we'll have Ellie and Leon do number 5 right there.
I was thinking I will put them in the middle of the
Right, so in this case here, you'll make sure your dimensions are correct. They're the same dimensions. So then you would add each element. So that element maximum value. So negative 5 plus 0 gives you negative 5. Negative 6 plus negative 6 gives you 0. If you go to 3, and the answer is still 2 right here. Who's doing number 2 over here? Oh, there you go. Right. All right, so that's the way that works. To subtract,
I have never been someone who
multiply by negative 1. Then add the okay? Nothing comes easy, girl.
You're right. Wait. I just have allergies because my doctor retired. So I didn't give it. It's negative. Oh, makes it possible. Oh, I'm sorry. Are we doing my events today?
Yeah, we're pitching it.
Wait,
Is there
where
no
is
solution? The majesty. Yeah.
do we?
Yeah.
Can you listen?
Actually, no, we got to do
Mr. Love.
We have a groundhog in the backyard, so we named him. He shows up every day, so we sit there, we eat dinner, and we watch this groundhog go around the yard and close the door.
Okay, sorry about your girl. Can we leave off here? Yes, sir. Is it on? I don't know.
Scan something.
I really thought about doing understanding.
That's you say something. Hold on. See what my canvas looks like. I'm pretty confident that I did post it, so. Oh, I was working on it because it's on my YouTube channel right now.
So what's going on again?
It's going on right now. Where's my content? I'm going to channel content. There it is. Copy. Edit.
It's like the marketing classes, but it's like it's a lot. It'll be marketing. We're great. When did you get like? I did on the exact same. Oh, it's fine. Yeah. No, you're a soldier. I don't know how you're getting that. I haven't done it. No. I had her first.
That's that. All right, it is now posted.
Yeah, so, okay, the difference between Miss Wilkins and
Thank you.
Miss Miss Wilkins, she's pretty like laid back, she doesn't care. Miss Allen is like, oh no. I don't know how I would have gotten it. I got cheese, to be honest. I was so happy. It just, it was funny. That song, I would listen to it. Like, really, I don't even remember anymore. I had it remember. I got it small. I got all of it's just constant. Yeah, bro. I put it on to tell you a single thing. No, I'm really kind of like I'm gonna say, oh yeah, I took it. No, didn't have it did not. It's just, I hope you don't get on the top section. That's the worst. But I can also fight. But I also did it online. I did it online and just did it. So y'all online. Yeah. I was like, the whole class. I mean, as long as you got through.
You have to sign out. Put your name in there.
Are you serious? I'm in class, in the middle of class. Almost.
All right, let's take a look. All right, so add and subtracting. What has to happen in order for you to add and subtract, guys? Same dimensions. When you are doing and you have same dimensions, then it is all location based, right? So A11, remember the first element is going to be added to the other elements. So when we subtract, all right, we do the same thing. So that element is going to subtract that element. So you got a 2 by 3, and we have a 2 by 3. So wait, if this is a 2 by 4, then you can't. Okay? They're separate. So what was the fastest way in order to make fewer mistakes when you're subtracting? Change your signs. So this is a quick way to help you make fewer mistakes. Not to say that there are any mistakes up here, but this would be a plus, a negative, and then if you switch these signs, then I can think of -1 and -4 to get to -5 quickly. Otherwise, I have to think of what's -1 opposite. And you're doing 6 problems. You're going to make a mistake if you keep doing that. All right? So it's faster to switch. So here I get 10. Here I'm going to get -5. Obviously -10. 0, that's probably 6. And then -19. Good job. Okay? So on the basic matrix quiz, if you did yesterday and you now understand elements and you know your dimensions and you know equivalency fractions, you're good. You can add and subtract. You're going to be good on the quiz tomorrow. I should have lots of hundreds. Okay?
Wait, is multiplication?
That's for what? She doesn't read. It's okay. She's good at math. She can't read.
Yeah, I couldn't really see.
I'm blocking.
All I see was basic.
Like the blackberry dragon.
I didn't see what?
You know the blackberry dragon. All right. All right, so number 3, we had to distribute a -2. That is just scalar multiplication. Good job there. Just multiply by -2 to everything. Number 4, feel good about it? Number 4, you feel good about it?
Yeah.
It looks pretty good. I think you got it right. And number 5.
Okay, can you not multiply this with
You made a mistake back there.
I'm so confused.
We'll do those together. We're gonna do number 4 and we'll do number 4 and number 5 together. All right, so there is something you have done incorrectly on number 5. I don't know where it is. So in this case here, when we're taking a look at this, guys, again, I showed you 1 yesterday. Again, just showing you 1 is not going to be enough, obviously, right? You're going to have to see it several times. Guys, if you created this matrix, and let's just make that a number. Let's say I had 5 plus 2x is equal to, let's make this 7. What would you do to solve this equation, Mary Beth? Yeah, you subtract the 5. So I get 2x is equal to, let's say, 2. Now, Lily, what would you do? Then you would divide by 2, which is the same as multiplying by what? 1/2. We want to think of it, instead of division, we need to be thinking of it as an inverse, or we're multiplying by the inverse, which is 1/2. Guys, that is the same thing we're going to do. It just happens to be lumped into 4 different numbers. So there's 4 numbers here. We are going to subtract this matrix right here from itself. What happens when you subtract that matrix from itself? When we subtracted 5 from itself, you got 0. This goes away, which means that we have to subtract this one over here. Okay? So this is going to go away over here on this side. So now, since I subtracted that over, this is gone. Okay? Does that help visually? There's no plus sign there anymore. Now we're going to do some math over here. I'm subtracting, right? If I'm subtracting, then I need to change that to a what sign? To a plus. And then switch all these signs in here. Then that way, when I get this, I get 2x is equal to, when I add that, again, I think it's -6. And I want to say I get 8. And I want to say I get 0. And I'm going to get 5. Peyton, you with me so far?
Yes.
Haven't lost you? All right. So, what do I do with the 2? Multiply by 1/2. So I'm going to distribute the 1/2 to everything, okay? Which is the same as dividing by 2 to each and every single one of these. So I'm going to get a -3, a 4, a 0, and a 5 over 2. Just like they did on the board, okay? So good job. All right, ready to work for number 5? Because that one's a little bit different. This one's laid up in squares, and that one's laid out like in lines, you know, like a whole bunch of real long matrix there. So let's fix that. Remember, in this case here, if you need to start off and you have to try to figure things out, here's another way you can do this problem real quick. I showed this to you yesterday. All right, so my matrix here is going to end up being a 2 by 2 matrix. You can take 2, 2x, and 4 and write an equation. You can write that as 2 plus 2x is equal to -4. You could also went -8, doing this one, this, and this. You could write down -8 plus 2x is equal to 0. And you just continue the process on all the locations. You would get, in this case here, an equation matrix, basically, all right? So I could do this way. If I solve now, if I try to solve for this one right here, let's just solve the one that's in purple right here. I would move the 8 over, get 2x is equal to 4, divide by 2, so x is equal to 2. I guess that was wrong. That's an 8, and that's a 4, sorry. I knew it was wrong when I wrote it down. It just didn't feel right. So that number right there in purple was 4. Well, that's exactly what we have over on the board. That's what we had earlier. If I solve each of these equations, I'm going to get the answer. So you could create equations here, 3 different equations for the one that's underneath. So for instance, you see this 6, the 3x, and this. You would have to go like 1, 4 times 6 plus 3x is equal to -2 times 1/2. That would create the very first one. Then you would have 2 more. That's not efficient. Okay? Doing it this way is not the way to we would like you to do it. All right? We want you to think of it this way. If I have 1/4, 5 plus 3x is equal to -2, what would you do here when you're solving this problem? What would you do first? You would multiply, right? I'd multiply that, and I'd multiply those together to start with. Okay? It's not any different. I'm going to take the 1/4 and distribute here, and the -2 and distribute here. Okay? Kind of like what they did on the board. They started off doing great over there. So let's see what we get. So what is 1/4 times 6? What is 1/4 times 6? What'd you say? You said 2? I don't think so. You get 6 over 4, and as you guys said, it is 3 over 2. Okay? Huh? I don't know. And then what is 1/4 times 2? 2/4, which is 1/2. What is 1/4 times 4? That's 1. So my 1/4 is now gone. I got plus 3, and then I'm going to go ahead and multiply. There's an X right here. And then I'm going to multiply the -2, which would give me what? -1. -4/3. And +2. Now I'm back to this type of equation we just did. Okay? So once I have it, now I have kind of narrowed this down to this equation. So what did we do with the matrix on the left? We subtracted. So I'm going to write it up here so you can see it a little bit better. I'm going to go 3 over 2, 1/2, 1. Whoops, take that back. I'm subtracting that one. I'm going to get 3x over here. When I subtract, it disappears. I want you to understand that. I get -1, -4/3, 2, minus 3 over 2, 1/2, and 1. Sometimes my eraser works, and sometimes it doesn't. This pen is just a clanker. All right, now. You know what clanker is? It's an old, useless robot. All right, now. Sure? It's like an old flip phone. Flip phones are clankers, right? Yeah, I like using that word. As you can tell. I drive a clanker. My second car is a clanker. It's a 2009 Honda Odyssey. But it gets me where I want to go. All right, so we're subtracting. So what do you need to do with these numbers here, guys? Make that a plus. Switch the signs. Out of the 3, which one's the easiest to do? The one on the end, right? There's only one number you can do really quickly here, and it would be 2 plus a -1, which is 1. Now, the very first element, this -1 and this -3. So -1 and, -1 plus -3 over 2. Anybody know what that's going to end up being?
Negative.
So that's going to turn into 2 over 2, which is? Correct. Then we have, and I'm going to scratch this one off to the side as well, because I do have some fractions here. I have -4 over 3 plus a -1/2. How would I add these fractions together? Yes, right. I wouldn't multiply by 6. I need to make, the common denominator. Yes, right. I misheard you. I am a Guzzy, so I have, it's an old person. But Huzzies are not, it's not a good word. So Guzzies are not necessarily a good word either. But
How old are you?
how old do you think I am?
58. I would say like 40. No.
58. I like it.
56. 54.
All right.
How old are you actually?
I don't know how old I am. All right, now. 21. Ask Maddie Grubb. She knows. All right, now. 19. Just ask Maddie Grubb. She knows. All right. So in this case here, this one's -8, right? And that is -3. So what do we get? Is it -6 over? Hold on, did I do it right? It's -4/3 and -1/2. Yes, it gives me -11 over 6. Okay? Last but not least, what are you going to do with the 3 out here? There you go. Got to multiply by 1/3. So x is going to equals -5 over 6 minus 11 over 18 and 1/3. There is the answer. Okay, so was that a tough problem? Yes. You have it in your homework right now. So what could you do if you wanted to practice that problem? You could write it down on another sheet of paper and try it without looking at this. Then see if you can get the answer to match. And if you need to see the explanation, it's on there, and you'll hear me talk about clankers. Okay? So there you go. Any other questions on your homework?
What's 2 times 2 over 5?
Huh?
2 times 2 over 5.
2 times 2 over 5? 4 over 5.
4 over 5. Thank you.
Yeah, you're just doubling the top number anytime. It's 2 over 1 times 2 over 5. Yeah. Any other questions over your homework? We're going to move on to notes and start multiplying matrices. All right. So make sure you practice. Yeah, I love it, Carter. I love it. It's awesome. Yes. All right, part 2. We're doing with this right here. Let's go. We're going at DA. So we stopped. Yesterday we stopped. We did number 5, which is -2 CE. So now we're doing the DA. You guys know what that is? No. Dumbledore's Army, right? Do you know Dumbledore's Army?
Yeah.
Yeah, it's all about Hogwarts. Yeah, that's right. Remember, Dumbledore created an army, all right? He was up against Umbridge, right? Professor Umbridge she was a great.
Are you struggling? Oh my gosh, Colton, if you're talking
Teacher
about this,
or a leader.
real quick.
That's my cousin.
Colton, my mom is on the
She did good things for Hogwarts. All right, now. Yeah. So D is 1, 0, 0, 1. Write this down, guys. You're going to be doing this one. You're going to multiply these together. So I'll try to refresh your memory on this, on multiplying. All right, so this is day 3 of multiplication. This is a new pattern you had to learn. All right, it's all about the bug, right? So you can remember the buzz, maybe it might help you. Now, what is the dimensions of this first one? So I'll need you to write down 2 by 2. And the other one is 2 by 2. Can you multiply these together? How do you know? Correct. So the ones in the middle match. If they match, then that is a yes. If they're different, then it's a no. So if it's a no, then you say cannot multiply. All right? So now we're going to multiply these together. I'm going to create a work matrix. Okay? Over here is going to be a work matrix. This can be fairly large. It will be a 2 by 2 matrix. Now, since that is a 2 by 2, then we're looking for this first element. That is an A11, right? Remember what 1, 1 meant? Row in, column. So we're looking at row 1 and applying it to column 1. So row 1, column 1. Okay, again, I created a bug here so you could see it and understand that this little bug is going to crawl into this spot right here. You're going to crawl into that spot right there. The numbers that are corresponding here, the 0, 1, let's say the 1, 0, is going to be here, right next to these two numbers right here. You're going to multiply those two numbers together and add them. So you're going to write down 1 times 1 plus 0 times 3. Okay? 1 times 1 plus 0 times 3. I got it. All right, so remember that bug is covering the first column. Now, remember the bug's going to crawl into the second location here, all right? He is really just going to kind of slide down to the next column. So the 1, 0 is now going to be here. So you got 1, 0 here as well. So you're going to multiply those two numbers together. I'll do it in green to separate it so you can see it. But it's going to be 1 times negative 1 plus 0 times negative 2. Right? That gives you the second one. So guys, you are taking this, remember, you are taking 1, 0 and just really flipping it here and then distributing it across each of the columns as you go down. All right? And when you multiply each of these, remember, they are kind of a stack of numbers you're multiplying. You've got to add those together and then combine to create that very first element, the second element, or whatever one you're looking for. Okay? So when we're moving to our next one, okay, we are taking this column right here, or this row right here, and you're going to apply it to this column here. Again, it's going to slide over, and 0 and 1 are going to go there. You're going to multiply these together, and you're going to add it to the multiplication of these together here. Remember, that's row 2, column 1. Row 2, column 1. So that way they match, okay, your location. We continue the process. Can't do it different.
I did not do it.
Can't do it different. It has to be this way.
Well, I got a same answer.
Wrong. All right, now, matrix multiplication only works this way. Any other process will not work. Well, it can probably give you the same answer, but it won't work on the other one you multiply correctly on other ones. This is because this is a very unique number here. You're going to find out here in a second what this is. So when I multiply this together, I get what? Negative 1 times 0 is 0. And I'm going to add it to the multiplication of those, which is negative 2. Now, I'm going to get a final result over here when I get done. That's going to be 1, negative 1, 3, and negative 2.
Hey, look.
Okay. And you did it wrong. Because if I put numbers in there that are not 1, then you would have messed everything up. So you've got to follow that process. The process cannot be changed. All right? It's got to be rows and columns, and you add rows and columns. Now, what did you guys notice about the answer?
I think we have some.
It's that number, right? It's what we started with. It's A. What number can you multiply by and get the same numbers? 1. So this is the number 1 in matrices right here. That's the number 1 in matrices. When you multiply it by 1 on either side, doesn't matter where it is actually commutative in this case. One of the 1 matrices that actually creates a commutative property. All right. So this right here, if I do 4 times 1 is equal to 4. You might know what property that is. Or 4 plus 0 is equal to 4. You might know what that one's called. Close. It's not commutative. It's not associative. It's not distributive property. There's other ones. We had them in our notes yesterday. Or a couple of days. It's in the packet somewhere. Page 2, possibly. Page 3. Oh, it's in the other notepad. It's in note set 1. So. It's in note set 1. We got note set 1 in with it? We talk about this property. It's one of the properties we have to know. I am who I am. This is the way I learned this when I was in college. In high school, I learned this as I am who I am. Starts with the letter what? When I say I am. Starts with the letter I, so that always helped me. Identity. Okay? So this is the identity matrix. Identity, I can say, matrix is this one. This is what we call identity. All right? This is additive identity, and this is the multiplicative identity. So under matrices, we actually have a multiplicative identity. We actually have that, so it does work. So like I said, there's bits and pieces that work. Multiplication doesn't work all the time, correct? The dimensions have to match up for it to work. Addition doesn't work all the time. Dimensions have to work out for you, all right? So there are pieces and parts, which is really kind of cool, that the numerical system that you use, all just single numbers, yeah, we actually can use that, and then we can apply some of those properties to matrices. Which means that we can take hundreds of pieces of data, thousands of pieces of data, and manipulate them quickly. Okay? And that is what matrices are good for, is that we can do certain operations. Not all, as we know yesterday we can't divide, right? But there are things that we can do to apply, which is really kind of cool. Okay? So this is identity. Now notice that the shape. What is that shape of that one? You might remember what a 2 by 2 is. The what shape? It's a square matrix. Okay? Identity matrix have to be square. What else do you think has to happen? Let's say I have an identity matrix that is a 3 by 3. I want to take a guess at what it would look like. Yes, it is 3 by 3. That's the size. But what would be inside it? I have to have a 1, right? I would have to have a 0. You think it's a 1 right here? Nice try, but it's actually 0. That's a good guess. Okay? There is a matrix we use that is 1 and opposites, but it's signs. So when you get into a little bit further, we have a plus, minus, plus, and minus, plus, minus, and plus, minus, plus. We use signs matrices to manipulate some of these. So we won't do it in this class. But the further you're in matrix algebra, so you'll get some. I always thought it was fun. Yeah. I made it almost 100 in this class because it's, to me, it was new. Right. I'm not working with parabolas and I'm like cubic roots. I don't know. I was just loving the patterns. So that right there is an identity matrix. It has ones and zeros. Okay. Moving on. Let's slide over to part 3. Okay. So is matrix multiplication commutative? No, it is not. Okay. We know that it is not because, well, we can just do this one right here. What is AB? A times B. Let's go ahead and multiply A and B together. Let's see what you guys get. We can do this fairly quick. And then you're going to test it to see if it's BA. So go ahead and multiply A, B together, guys. Where are your notes, man? I should take grades on notes. Since I got people who are not taking them. We should take learn a lesson from topic. So this is it. All right, so you should have gotten what, 5, -2? So again, you're multiplying this row right here with this column. So 2 and 1 goes here. So you would get 2 times 2 plus 1 times 1. And then you would do the next one, which would be 2 times -1 plus 0 times 1. Oops, sorry. It's supposed to be underneath it. I messed up. My location was that. So this will equal 5 over -6. Not over. Yeah, there you go. Questions? Anybody have any questions on that? Did you get it right? What'd you notice about the second one? Oh, I didn't put my dimensions. I didn't check it. 2 by 2, right? This is a 2 by 2, and this is the 2 by 1, so it allows me to multiply. This one here is a 2 by 1, and this is a 2 by 2, and guess what? Can multiply. Commutative property, done. Can't happen. Doesn't work. Okay? Sometimes it works. Had that been ones and zeros in a square matrix, yeah, you could multiply each side. It would have been fine. It's a all right. So now we have a matrix. Is it associative? Is the question we're asking here? Does it follow the associative pattern? Well, in this case here, we already have A, B done, don't we? We multiply those together. We said that was 5, negative 2. And then we're going to multiply it to C. So this is AB right here already. And we're going to multiply it times C. C is what? 1? Is it 1 or negative 1, 2? 1, 2? It's just 1, 2. So we're going to multiply those together. And then we're going to come over here and check. Or we're going to take A and then multiply it times B times C. C I know is 1, 2. Now you have to do them in order. And then B was, what was B? 2, 1. So I'm going to multiply those first. Then I'm going to multiply A. And A happened to be something larger, right? Wasn't it 2 by 2?
2, 1, negative 1, 0.
2, 1, negative 1, 0. Times whatever that result is. All right. So we're going to check to see if it's associative. They're identical. This is a really tough one for a lot of students there, Addison. What's your dimensions for this one? Addison? So that's a 2 by 1, and that one is a what? 1 by 2. So those match. So we can multiply. What's your answer matrix going to be? A 2 by 2. Does that make sense? The outside creates your answer matrix. Okay, does that make sense? So when you get done, you're going to end up with a 2 by 2 matrix in the end. This threw A block off a little bit there, Katie. Because what is your row? Your bug is this, right? Here's your bug, right? And it's going to go where? Right there. So what do? So that's just a 5 on top of the 1. So it's just 5 times 1, right? Do I have to do any addition? No. There's no stacking, and that's what really kind of really kind of bothered them, because we're not dealing with a centipede in this case, right? In this case here, we're just dealing with a roach. So, oh wait, I shouldn't have used that word because you guys use your recreational drugs. All right, now. Roach was a drug propellant, right? Isn't that a drug? I got a roach left in my. Oh wait, sorry, that wasn't Gen Alpha or Millennials. That was more like Gen X, right? Probably. We used to call it Mary Jane. What's left over is a roach. These things I only know not by experience, because I don't actually do drugs. I've never smoked pot, so that is one thing I will never put in my body other than camp smoke when I'm sitting by a fire. You know, that's about it. Well, actually, when we didn't have vapes, because right now when I go to the bathrooms, I get vape in my lungs because I get secondhand vape, and I'm probably going to die from cancer from that. So before that, they had cigarettes, so we would come in here and we would have I get secondhand smoke in there. So I.
People actually smoke cigarettes in this room.
They used to, yes. So I should get -2 and -4. Smoke is not good for you. Little small particles going into your lungs. It's not good. Water vapor filled with chemicals is not good for you. I just don't get it.
I got it right.
I don't quite understand the concept, but I don't know. Maybe it makes you cool. Okay. Maybe you look really cool doing it. I don't know. So maybe that's the reason. Good job. All right. So let's do this one. This one. Good job. You need to. This is a 2 by 1. This is a 1 by 2. So we get a what? A 2 by 2 again. So 2 times that is 2. 2 times that is 4. 1 times you get that. Anybody have any questions on that? should have been pretty quick. Remember, the 2 is being applied to that one. Each column. That's what it did. Just doubled it, and then it stayed the same. Now, I'm going to multiply this one. This is a 2 by 2, and this is 2 by 2. We can multiply these together. So this one has a little bit more work. I'm going to take the 2 and the 1, and then multiply them and add. So I'm going to get 4 plus 1. The next one, I'm going to have a 2 and a 1. Multiply and add to be 8 plus 2. Then I'm going to multiply, then I'm going to use the -1 and 0. So -1 and 0, and apply it to these. So you get -2 plus 0 and -4 plus 0. And what did you guys notice? They're the same. Guess what works? The associative property. Now, the way I remember associative property, and I know some people don't, but it's the multiplication of the first 2 and leaving the third one out. Okay, the way I remember this, like, associative property has the word what in it? All right? So, when you have 3 people, you have 3 people who are communicating. If 2 communicate, they're always talking about the blank. So that's the way I kind of remembered it. Then the other 2 get together and they talk about the other blank, right? So the associative property was easy for me to remember because I just said, somebody's making a blank out of themselves in this way. And so that's the way I remember it. Commutative property, when I did AC is equal to CA, in commutative property, I remember this is just communication to me. That A communicates to C and C communicates to A. So you're just switching back and forth. That's the way I thought of it. Identity matrix, identities were easy for me as well because I said I am who I am, right? And so you have it under multiplication and you have it under addition. That would be called an additive identity, and this is a multiplicative identity. So that's the difference. So that's the way I kind of remember those properties. So if you ever want it, distributive property was easy. Everyone just distributes papers, so everybody gets one. So this is distributive property. Okay, so if you're ever trying to remember those, maybe that might help you. Oh, and the transitive property, you remember transitive? Transitive has to deal with when you're doing proof writing, but it is the associative property just with statements. It's the same thing. It's just doing the same thing. So, I don't know. That's the way. You probably, I don't know if you'll have that question. It is something that we ask when we make sure you understand that there are only certain properties that work with matrices and certain properties that don't. It's important to understand that because, again, there are patterns in life that happen, and then there's certain patterns that you can't apply to something else. And that's what happened. We were just talking this morning. I was going through McDonald's, and the girl handed me my food first. And I've been in that store, I don't know how many times, and they always hand me my drinks, like, instantaneously. They go, all right, here's your Coke, here's your Diet Coke. And I get those, and then they hand me my food. I'm telling you, I've probably been there several years going there. And then today, I get my food first. And I actually mentioned it to my wife. I said, she handed my food first. I said, she's not as efficient as the other one. And they're like, what? Well, because she had to wait on the food, right? The drinks go in first, and then the food is hands me, because that way I can just pull out, grab the bag, and go. Not wait on the drinks. You should have had the drinks to me first. I don't know. But anyway, I just see it as an inefficiency in my head. That's why my mathematical brain works. So this is my ADHD
Did that really
brain.
upset you? Did it really upset you?
It doesn't upset me. It just, I'm aware of it, which is hyper awareness. You get what I'm saying? ADHD has, in our family, you get very, very hyper focused on certain things at certain points. And so my daughter, who is severely ADHD, she will get hyper focused on plants. So she went out and bought lots of plants. We actually drove down to Florida to get certain tropical plants that she wanted. Okay, we kind of just, number one, we were looking for a trip. We didn't know where to go, so we went there. So we stopped at a greenhouse, and out in the middle of nowhere, she found and bought some tropical plants. Came from another country, which were kind of expensive. But she got hyper focused for, I didn't say 6 months, 8 months, even worked at a plant store. So and she moved on to something else. In college, the first 2 years in college, she was hyper focused on makeup. And so, can she do makeup? Heck yeah, she can. She actually, while she was living out in California out there, she did makeup for an art, I'd say a rap video. And so she was one of the artists painting faces out there for her. So she's not hyper focused. Does she do it? No, she doesn't do that for a living. She doesn't even, I don't know, she doesn't put that much makeup on me anymore, not like she used to. So it's just kind of crazy, but it's just the way she goes. So she has a really bad problem with I call it a problem, but it's not. It's just her quirkiness. So when she comes in the house, she'll have some coffee, and she'll get it down to about a third, and then she'll set it down, and she'll forget that it's there. And so we'll leave it thinking she's going to have it, and then the next day it's still sitting there. And she's already got another coffee, and it's sitting over here. She totally doesn't even know that one's there. She forgot it was hers, and she forgot to throw it away, and she doesn't even realize. She's blind to it. She is literally blind to it. And so we will end up with little food wrappers and trash. And then she has to actually remember, so we have these little things that we've been giving her, like a medallion, and it says, hey, take your medicine, or pick up after yourself. And so she gets up in the morning, she sees that, and guess what she does? She cleans up. She does this. So those little things have really helped her calm her mind and being able to calm her life. Because she doesn't see the clutter, but eventually the clutter's there, and then all of a sudden she's aware of it. And then she's hyper-focused on the clutter, and she goes, the walls come in, she panics, she's got a panic attack. She'll end up breaking down, crying, calling mom and dad. Oh, I can't do this, I can't do that. I'm just so far behind on my work. I haven't graded my papers. And really, the clutter is what caused some of the stress on her. And she just, if she starts to be aware of these things, she does these little things. So for the last couple of years, she's matured. She's done so much better. She doesn't call us at the drop of a hat anymore. It's crazy how much she has grown. So, she teaches college. She's working her PhD in math. So yes, so she is super intelligent. Smarter than me. She's working on her PhD. She teaches Calc 2. If you have a calculator, go ahead and get it out. I learned a lot about ADHD.
Are we done with this pocket of notes?
Yeah, I think that was it, right? I don't think I have any more other than the identity in your stuff. Hey, let me see. This too. Oh, yeah. Good job.
Get the reference down. No. Get the reference down.
Yeah, this tells you step by step how to do and solve a system of equations. We have to what, 38? So I got 4 minutes? All right. So guys, remember in this case here, you have 2x plus 3y equals or minus c is equal to 9. So you are going to create a matrix, and you got to make sure that your x's are lined up, your y's are lined up, and your z's are lined up. Okay. So what do you notice about the third equation? There's no what? So there's a 0x there. We are going to create a matrix. 2, 3, negative 2, 9. 1, negative 1, 4, 6. 0, 2, 3, 12. What size is this matrix?
3x4.
It is a 3 by 4. Okay? You're going to take that 3 by 4 and you're going to plug it into your calculator. I'm going to pull my calculator up so you can see it. Second matrix. Slide over to edit, just like we did yesterday. Punch it in, 3 by 4. So you got a fairly large matrices. Enter your data in order. X's 2, 3. Whoops. You got to make sure it's completely right. I messed it up this morning. All right, for double check and make sure all your data is in right. What do you do next? Once you have your data in, you've got to second quit to get out of there. Now, we're going to calculate. So you're going to make the machine do reduced row echelon form. It's RREF, not ref, but ref. All right. The second matrix. When you go over here to math, you can arrow down or arrow up. Arrow up is shorter to get to RREF. It's the letter B. You will pick RREF. You now have to put your matrix in. So second matrix, pick A, and what happens, you hit enter.
Wait, what'd you do after RREF?
You go back to matrix, pick your matrix. Matrix A.
Okay.
All right.
And then what do I do after this?
Hit enter. Once you hit enter, it solves it. Guys, what column was this column? That was the X column. So X is equal to 1. This is the Y column. So Y is equal to 3. This column is the Z column. So Z is equal to 2. Anybody know something special about this answer? Yeah. Houchin says this thing, which is called a what? Identity matrix, is here. Now, echelon, the E stands for echelon. Echelon was a famous mathematician who worked with a lot of matrices. He has, and he takes these equations and creates, you start with your numbers that we had, and you're going to add, subtract, divide, multiply. Eventually, you'll end up with your identity matrix and your answers. It's called reduced row echelon form. We call it augmented matrices. So tomorrow, we're going to learn how to do this on a 2x2 by hand. Okay? Everybody, it's easy. What's calculated stuff to that?
I feel like there's any questions to go from afterwards.
No.
I couldn't.
I thought so, but I teach it every day.
No, I can't do it.
All right, so hey, Dad, thanks for turning down the thermostat. I say, don't sweat it. I used to have a conspiracy theory about single beds, but it was debunked. See you guys. Have a good day. Yeah, absolutely. Keep it up. I am so proud of you. I like the last name. See, Mads? See, it works. Carter, you passed, I think, the test yesterday. I think so.
Oh, I passed.
I understand
You
the
graded it
fast
wrong.
food thing because I work in fast food. So when we're training people, I always tell them hand out grades first. Because when I hand out grades, they're like, hey, you go to the sauces. That way I can grab the sauce.
That's efficient.
Anytime they don't do that, I'll just serve them with this.
Yeah. It just like, she sat there and was talking to the other employee. And then waited. I was like, why are you not hanging on me? I just wanted to walk up to the Hey, well, there's a manager there. Well, the big wig was in the store. Where do I park in the park? Wow. This is the fastest way to move from the maybe a weekend. Don't you want the notes? Yes. Also, because I'm just for like 7 kilometers. And that's just because like today, No, I think would be over there. Wait, no. You have the opener?
Yes.
The second Nora, the Explorer.